Welcome to another edition of Fun with Games using Excel VBA. This game is the classic Pong game that everybody remembers from, or may not remember from the old days or early days of computers, and it represents a tennis game. So here in Excel, I've built my version of Pong, and it utilizes class objects. So we create some class objects for the batons or paddles, whichever way you want to call them, and the ball. We use user 32 API call for keyboard input from the user, and this is used in conjunction with on keys to set the behavior of those keys. We've used this process before, and we used it in the snake game. We also have a game timer, and that game timer moves the ball around the screen, or at least sets the time for the ball to move around the screen, and that's also similar to the snake game. The other thing we introduce here with this game is collisions. How to detect whether our ball has hit a boundary or has hit a baton, and also what to do with the ball once it's hit a boundary or hit a baton, and also what to do when it doesn't hit a baton, when it hits one of the side boundaries. How do we represent that play? So let's go on and have a look how the game's played. Playing the Pong game. Pong game has two areas. There's the play area, the court, in which the ball and the paddles move and the score is kept. And then you have the user variables. Let's have a wander through the user variables first. Winning game score, that's the threshold to win the game, so the first player to 3 wins the game. Game speed, that's the speed at which the game timer works. And there are a set of steps, and we can see from the comments box that 1 equals 0.5 seconds, and so on. Baton speed is the number of pixels the baton moves at each press of the keyboard. So in this case, baton speed is at 3 pixels at a time. So that means that the baton moves a little bit faster. If we set this to 1, that would be the slowest speed, and the baton would move 1 pixel at a time. Ball speed works in much the same way as the baton speed, in that the ball moves, in this case, 1 pixel at a time. Or we could set it to 2 pixels at a time. The higher the number, the faster the ball will move. Next we have new game, and this resets the game and starts play for a new game. But we also have 2 extra buttons. We have end, which will stop the game in play, and clear, which will clear the screen of the batons and the ball. So we'll press clear here to clear the screen. Now we don't have to clear the screen, but we've done so as an example. And then further down we have an indication for the user. Player 1, its up key is A and its down key is Z. And player 2, the up key is the arrow up key, and the down key is the arrow down key. Let's play a new game. New game. We move the paddles around, and depending on where the ball hits the paddles, depends on the reaction of the ball. Now to score, the ball must pass the paddle. When the ball is served again, it's served from the winning paddle, and that's a random process. Now depending on where the ball hits the paddle, depends on how the ball moves. And we can see that the ball is randomly being served in another direction. And the first player to the threshold, which in this case is 3, is the winner. And we have a message box, select a new game to play a game. Now if we select new game, but this time we end. End stops the play and shows us a message. Select new game to play a game. Now we have a choice. We can either clear the screen or we can select new game. If we select new game, we can see that the screen has been reset and the game starts all over again. Here we explore how the user interface was made. So let's go and have a look and unhide some things, headings, grid lines and formula bar, to see how the gameplay area looks. I've reduced the size of the columns, but I probably didn't really need to because we're using shapes. The last column here is BK1 and the last row is 31, so the gameplay area or the court is A1 to BK31. And this court we created using background colours, so dark blue for the left-hand side of the court and dark blue for the right-hand side of the court. For the central line, we also used the background colour, light blue for the central line. We have shapes representing the score, and we've named these SHP P1 score, SHP P2 score. And if we look at shape format, we can see that these are word styles. We have other shapes, and we have the batons, and that's SHP left, SHP right, and the ball, SHP ball. These shapes are created during gameplay, and we can kind of see that when we press clear. When we press new game, they reappear again. If I click end, we can stop the play. So we can see that the batons and the ball have been created during the play, but the score and the background for the game are static. Looking at the user input, we can see that each input has a named range: end score threshold, end game speed, end baton speed, and end ball speed. New game is a shape, and we assign the new game macro to it. Likewise, end is a shape, and we assign a macro end game. Again, clear is a shape, and we assign a macro clear shapes. We create the buttons in a similar way. We fill them with a colour, in this case light blue. We give it an outline, slightly darker, and we make a shape effect of bevel, and it's a rounded bevel. Further down, we add some text to give the players an indication of the key presses they need to move the batons up and down. And that, in a nutshell, is the user interface. Looking at the Visual Basic editor, we can see that we have Sheet 1, Sheet 2, Sheet 3, this workbook, which has a call to reset on keys on the action workbook before close. We also have a set of modules: MDL game, MDL on keys, MDL timer key state. And we have a set of class modules: class ball, class baton. Firstly, we're going to deal with user input into the game via the keyboard and the game loop. First off, we set the behaviour of the user keys on MDL on keys. And here we can see we have some notes. Using Excel's on key allows us to override the default behaviour. In this case, the arrow keys no longer move the cursor around the screen, highlighting cells. Later, the on key events are used by the API call to the get async key state to call the on key behaviour. Initially, we have a global variable, int baton steps, as integer. This comes from the user interface, and this comes from end baton speed. Let me isolate this bit of code. We've had a look at declarations. We're going to declare on keys. Here we're defining the on keys, pointing to a separate sub for each key. Sub overrides the default behavior, and that's similar as explained earlier. And then we have a small narrative here that A represents up, Z represents down for player 1. For player 2, the arrow up and the arrow down represent their directions respectively. Our application on key statement: up, and then we define the procedure: press up, down, A, and Z, and we define the procedures for those. So let's have a quick look at those. So we can see A, press up. Here we have a with statement: left baton dot ypos. Ypos equals ypos minus baton int baton steps, and that gives us our left movement, our left baton movement, the Y position of the left baton movement. And we can see it's similar all the way down. So we see key press down, and we're using the right baton here, and we're in a with statement. Up, and we're using the right baton again, and we're using the arrow key press up. And Z, we can see we're using Z again. So the batons only move up and down, so we're only moving their Y position. Let's view all the code again. And finally, we have reset on keys. And reset on keys resets the key state to its default position. And the difference between setting the on key and resetting the on key is that resetting, we omit the procedure call. Moving on to MDL timer key state, if we isolate some of this code here, select declarations, as we can see we have some global variables. We have be on off, boolean, and that controls the game movement, and that really just tells us whether to start and stop the game. Global DBL timer value, that's a double, and we control the game speed through this. Initially, within the declarations area, we make our API call to get the key state for the arrow keys. This allows the user to interact with the game. So we have a public declare function where we get our getAsync key state library from user 32. We set our keys up that we wish to monitor. In this case, we're choosing the arrow up, arrow down, the A key, and the Z key. So we're choosing 4 keys, and we're choosing keys for player 1, A and Z, and keys for player 2, up and down. Next, we'll look at gameplay. And when the game starts, we make a call to gameplay, and gameplay is the main loop for the game. And we have a note here: during testing, be on off is assigned to a button. Later, it's part of the game control code. So we set be on off to true. That's our default state is true until we're told otherwise. And this code continuously loops through the game activity, moving the ball and taking in user actions as part of the game timer. This loop calls move ball and game timer. Move ball is where most of the logic of the game resides. We'll tackle that later. Game timer, that's called, enables us to interact with the game from the keyboard, and we'll have a look at that next. Game timer. Game timer brings in the time to delay the loop, and the loop here uses DBL delay time as a control. So we have timer minus start time is greater or equals than the delay time. Initially, we set the timer to the current time that we enter this procedure. Then we enter the loop where we start to monitor the keyboard via the API call. And each time the user presses these keys on the keyboard, these bits of code will be fired. So if the user presses Z, then we call the MDL on keys code Z press down, and we run that piece of code. The other thing we have in here is we have do events. Do events allows us to press the keyboard keys and have them recognized by the code. Otherwise, the code would run and would ignore any keyboard presses. And we keep looping until we reach the time delay. For further information on this, have a look at the snake game. Next, we'll have a look at the classes. We've got CLS baton, and we'll look at this class first. And if we have a look at the top here, we have general, and then we have our subroutines within there. We can see we have area, baton, and in baton here we have get and set properties. So generally, with our properties, we set and we get, but that's not a strict rule all the time. So we have height, length, name. We have our X position and our Y positions. We also have class subroutines, and we've set the initialize portion of that. There is terminate, but we haven't set any values for terminate. Private subclass initialize runs when the class has been created. This sets up the class ready for use. If we start at declarations, we set all our variables as private. So these are private to the class, and they can only be accessed through the set and get properties of the class. We don't make these directly accessible to the user or the programming. And we have comments on what these variables are doing. So p length is baton length, p height is baton height. And I've prefixed these all with p. And p, just for me, stands for private. So these are private variables within the class. And we can see here that we've got ypos, which is the y position, xpos, which is the x position, bottom, which is the bottom of the baton, the shape of the baton, and name, the area of the baton. If we take name as an example, we have get name, let name, we give it a parameter. And this parameter is name, it's a string. And here we say p name equals name. So whichever name we give the parameter, we assign to p name. When we want to use name, we'll use the get name property, and get name returns whichever values in p name. So how this looks in the code, let's go to game, create batons, isolate this code so we can see it clearly. And here we say set users defined class object parameters. So moving on slightly, declarations, we have public left baton, o left baton as new class baton. This instantiates the class for baton or paddle, whichever way you want to call it, but we call it baton here. And it's preceded with an O, so I know that this is an object. And for me, this is a class object. And when we declare this, we give it a name, and we're saying that we want to instantiate it immediately. So we're going to create a new class baton. So when this code runs, it creates a representation of that class. We also make a representation of that class for OWrite baton. And this does exactly the same thing. It creates the same class, only it has two instances. And these instances are separate from each other, but they use the same class as a template for building themselves. Going to create batons. This is where we first start to use the batons. And when the batons are created, they're given a set value. That's class initialize. And here we start to change some of its attributes. When we look at the left baton, we see left baton dot name, and we're giving it a value, shp left, and that value gets applied to the internal variable p name, but we can only access it through name. So in this instance, I say dot, I have all the properties available to me to use for that class, and all these properties were created by me when I created the class. Go back to name. If I wanted to use the name, I could type something along the lines of this, and my name would now be assigned the name of the left baton. So I can set the name and I can get the name. We can also see here that left baton, we apply its X position, and its X position is left or right of the playing screen of the court. And we can see here left baton is 20 and right baton is 535. So we're moving it over to the right hand side, and right baton here we see that we're also naming shp right. We also have a class ball which we've instantiated, and we apply its X position here. So that's how we're using the properties within the class. So let's go back to the class baton. Here we provide a way of getting the name and setting the name. I would say that if you need more information on classes, do have a look around. There's some excellent information on the internet and on YouTube. It is worth delving into. So if we have a look at our X positions, our property get X and our property let X, as we saw in the code earlier, create batons, we applied its X position. We applied a value to the X position or X pos for the left baton, and that had a value of 20. The value of 20 would be the parameter as an integer. That would apply that parameter to our private variable pxpos. It would pass xpos to the shape baton and its left position. The baton is a shape. Moving it left to right is moving its left position. So if we have a look at the screen, we can see our left baton is 20, and that's the xpos. And our right baton is 535. The ypos works in a similar way, and we've got some notes on the ypos let property. Sets the boundary for the baton and stops the baton from going off screen. What we've done here is we've said that if the ypos, which is the up and down movement of the baton, is greater than or equals to 1 and equals and less than 415, then we can apply a change to the private variable ypos, and we apply that change to the shape's top value, so we know where to position it vertically within the gameplay area. So that's the ypos, and they come in a pair as well. We have property height. Height is the baton height, so that's the shape height, and we set that with the parameter height, which is an integer. And we apply height to the private variable, and we also apply that height to the shape. And again, these come in a pair, a get and a let. Next we have length, and length again has a parameter length, it's an integer, and we set the private variable length, and we set the shape's width with length, and these come in pairs. The next pair, which is baton, we have a property get, which is the same as the other property gets, but instead of a property let, we have a property set, because we're setting the baton as a shape. When we declare pbaton, we declare it as a shape. When we apply a shape to pbaton, we must set it. So we use the set statement pbaton, and it takes an argument batonarg as a shape. Later, we fill it with a color, which we predefined. We give it a line color, which we predefined, and we make it shadow type ms shadow 26, and that's how we create the baton. Moving on to area, this was set in as a variant, and we have some comments here. This does not require a let property. Gets the area for the baton for collision detection. When returning an element, must use the element index. Use cls baton.area brackets index to return an element. So this is an example of the code to return a value from this index. Here we're using p area, and p area, as we can see here, is a double as value, but it's also an array, and we fill the array up with our property get, and we also apply area as p area. So we give area, the variable area, the array p area. When we instantiate a class, we run a class initialize routine. We have some code here which was used to help set the baton. So we say set baton equals worksheets Pong shapes as shape, MSO shape rounded rectangle. So rounded rectangle shape, and then it's the y-pos, the x-pos, length and height. This was set as text as an aid memoir to filling out the actual code, which is the same code as above, but instead of x-pos, y-pos, length, we're giving values. So we're setting the shape as an MSO shape rounded rectangle for the baton. We're giving its x-pos, y-pos, length and height as 0. We're saying we're creating a shape, but we're not putting it anywhere. The next thing we do, we're going to give it a generic opening position, y position, that is the top of the shape, at pixel 200. We give it a height of 50 and we give it a length of 10. So it's 50 long and 10 wide. And that's our initial setup for the baton. So that's the baton class. And really all the classes for us is a shortcut in the code. So we can have lots of code in a class, but we don't need to get bogged down with that code while we're coding. So it kind of happens to the side, so to speak, this code. Think of it as we're creating a black box. And in that black box, we have ways of interacting with that black box. And name is one of those ways of interacting with it. If we go over to MDO on keys and we have a look at the procedures press up, press down, etc., we can see that we're using the class baton and we're using its property, ypos, and we're setting that ypos a number of steps. So this number of steps represents the number of pixels to move. This code is a lot easier to recognize and deal with than looking at the whole code within the baton class. We can see here with our ypos, this is the code that's being run. Now instead of having this code every time that we want to change position in our main coding area, in our module, we can just call it here, and this is a call to that code. It just makes, one, we only have to change our code in one place, and that's the class, and two, it makes it a bit clearer about what we're trying to achieve and doing within the code. And that's the class baton. Now we move on to class ball, and class ball has a little bit more to it than class baton. If I isolate the code a bit, so if we have a look at the declarations, we can see that just as in class baton we have private variables, p length, p height, py pos, px pos. These are familiar from the baton class. Our p ball is a shape just as baton was a shape. We have p name, we have p area, we have additional private variables, and we have p direction, and this we have a note records the direction of ypos left to right. We have p plane, which it records the plane, which is the directional up and down. We also have a value for horizontal as well, so these are the directions the ball can move. And we have p out, and p out is whether the ball is in play or out of play. So they're the declarations, and they work in exactly the same way as they did for the class baton. Firstly, let's have a look at the initialize routine. So when the class is initialized, we set the ball, it's an MSO shape, and it's an oval shape. And we saw this same code in the baton. We set it with its values as 0, and then we start to give it a position and a size. So its ypos is 200, its direction is R, which stands for right, its plane is U, which is up, its height is 15 and its length is 15. So this is a circular ball, and we named this shape as HP ball. One thing to note about the ball class is that it was created using a copy of the baton class. So all I did was I created the baton class, then copied it, named it CLS ball, and then made adjustments accordingly. So it's incredibly similar to baton class, but it has some additional features. Looking through the coding, let's have a look at the area. This is the same as the baton class. We've got get ball, so we're using pBall here. We're going to set the ball with the parameter ball arg from the user stroke coding. And then with ball, after we've set it, we're going to create its colors, which are predefined, and its shadow type. Next, we're going to deal with length, and length is exactly the same as we've been through before. Height, exactly the same as we've been through before. The Y position. Now, the Y position, the property let for the Y position, this has some logic to it. And the logic is limit the ball to the boundary of the game. If the ball hits the upper or lower boundary, set the left-right direction tag. Now what this does, as previously in the baton, it works out the top of the boundary and the bottom of the boundary of the game area, the court. It ensures that the ball cannot go past that. So if we hadn't set this, the ball would just go off screen and just keep moving off screen. So we set these areas, whether we can move the ball up or down. The next thing we do is we see whether the ball has hit the boundaries. So if the ball has gone past those boundaries, then we want to rebound the ball. So the ball looks as though it's hit the boundary and it bounces off. So what we do here is we set its up and down plane. If the ball is moving up when it hits the boundary, then it has to be returned on a downward plane. And so whilst the ball is moving either left or right, it will have its trajectory towards the boundary. When it hits the boundary, it will bounce off. So D is opposite to U and U is opposite to D. So what we're doing with this else if is we're saying if we hit the boundary, then we're going to bounce off it. And likewise, if we hit the bottom boundary, we'll be going down. And if we're going down, then we need to go up after we've hit the boundary. So that's how we work the top and bottom boundaries through the YPOS coding. XPOS, we have a little more coding here. The property for XPOS, that tests whether the ball is in play or out of play. And what we say here is if XPOS is equal or greater than 1 or less than or equal to 551, which is the left and right boundaries. If the ball is in between these positions, then the ball is in play, and we set the out variable to true. If it's not in play, then it must be out, and we set the out variable to false. And this is how we recognize whether a player has scored a point or not. This is where the out variable is set p out, and we can see public property let for out. We just set the private variable p out to out, and that helps us control the ball in the game and know whether a point has been scored. Name is just the same as we've seen before. Public property get direction. Now direction is something new. We didn't have this in the baton class. We need to know in which direction the ball moves, and here we set the direction that the ball moves. And we use the parameter direction. The comments are for horizontal movement of the ball. R is left to right and L is right to left, and that's the movement of the ball. And we set the direction to either R or L. And here we just have an if statement that says if direction equals R or direction equals L, then P direction equals direction. So then we apply it. Otherwise, we're going to raise an error if the input is not R or L. So all we're really doing here is we've got a catch-all just in case whilst we're coding we do something that's not expected and we made a mistake in the logic of the game. So really all this if statement is saying for us is we're saying if we've made a mistake during coding, then raise an error so that we can see it. Otherwise during gameplay, what we're really going to do is we're just going to set P direction. In hand with direction, we get plane. And plane, as we can see here from the let, is the vertical movement of the ball. And the vertical movement of the ball is U for up, D for down, and H for horizontal. And these are the planes in which the ball can move. It will either move diagonally up, diagonally down, or it will move straight on a horizontal plane. If the plane value is U or D or H, then P plane equals plane, whatever the plane parameter is. Else, we're going to raise an error. And this is exactly the same code as we saw for direction. Next, we'll go on to see how these classes are used within the code, and we'll be concentrating on the module MDL game. Moving on to the main game module, MDL game. I haven't been through Option Explicit yet, I use it to force myself to declare variables, and the reason I do this is so that I don't accidentally create a variable with a slightly different name when I intend to use another variable. This is set in Tools, Options, and if we check Require Variable Declaration, that will automatically put Option Explicit of each new module that is created. I'll say OK to this, and I'll go to Modules, and I'll insert a module, and we can see that this module has been created and it has Option Explicit there already. When we run this code, we'll get an error when we get to test 1. So if I press F8, we can see we have a message, compile error, variable not defined, and automatically test 1 has been highlighted. We say OK to that. Now another way of dealing with this, debug and compile VBA project. What this does is it goes through your code and it tests whether syntactically it's correct or not. So this variable has been picked up as not being declared. We say OK to that. Now, if we get rid of Option Explicit and we run this again and we run debug compile, we don't have an error message. Now, if we try to run this code, it runs perfectly OK. So test was fine and the test has been declared. Test 1, that was fine also, but test 1 has not been declared. So we were able to create variables on the fly without declaring them. For myself personally, I prefer to declare all my variables so I'm aware of what they are. Here I've misspelt tests. Trying to pick tests up when you're debugging your code can be difficult. That's why I use Option Explicit. Now I run debug compile. I get an error message that I haven't declared tests. And if I try to F8 through this, I get a variable not defined. Moving back to the declarations on our module game, we have some global variables, and this is where we declare our classes. We create a class, OLeft button, and we set it as a new class. As soon as this declaration runs, we create a new class called class baton. And the same is right for OWrite baton. As soon as we create this class variable, we create a new class from the class baton. And we do the same with ball. We create a new class straight away. So as soon as this code runs, that's when we create our classes. It's only at a later date that we do something with them, but at the moment we've just created a class. Next, we have a set of private declarations, and these are just for this module, just for the code on this module. So we have string baton segment, and this we're saying here, we hold the segment where the ball collides with the baton. We have the scores of player 2 and player 1. We have int game over score, and that's the winning score threshold that we get from the user interface. We can see it here. And finally, we have int ball step, and that's the steps the ball makes per move. So that's the number of pixels the ball moves each time we press an arrow key. And that's the number of steps the ball moves each time the game iterates. And we can see it here. The game is initiated through the button New Game on the user interface, and we start here. First, we clear the game area of any shapes, and that is the batons and the ball. So we go to Clear Shapes and have a look and see what that's doing. So on Clear Shapes, we're actually using some error trapping here. I've not covered error trapping before, but what we're saying here is on error, resume next. So when the code comes across an error, it's just going to step over that error and run the next piece of code. And this is a way of keeping the game moving. We're saying here that we know we're going to get an error, but what we're going to do is we're going to ignore that error when we get it, and we're just going to step over it. So we declare S as a shape, and we're saying for each shape on active sheet shapes, so that's each shape on Pong, we're going to make it visible. With this select case, we say with the name of the shape, the last 5 characters is any one of these cases along here. We're going to ignore them. If they're not any of those cases, then we're going to cut that shape. That means we're going to remove it from the screen. We're going to delete it. And we do that for all the shapes on the screen. The reason we do that is we have the score and the buttons and we want to ignore those. We also make a call to clear objects. So we go to clear objects, and here we set the left baton as nothing, the right baton as nothing, and the ball as nothing. So we're clearing those objects. We also have a call to reset on keys. And as we know from before, reset on keys sets the on key behavior to the default behavior. On keys, reset on keys. And we can see here, we're setting the key values to the default behavior. Back to our new game. Now we're going to create batons. Create batons. And we can see here now that we're giving the left baton its position, its name, the right baton, its position and its name, and the ball is given its position. Back to new game. We're going to declare on keys. We cleared those in clear shapes. So we go to declare on keys. And this is where we give the keys a behavior. Here we're going to set the winning score threshold and player scores. Int game over score, that comes from the worksheet Pong, which is the user interface, and range, named range, end score threshold. This is where we say the first player that reaches this score wins the game. Reset the players' scores, and we reset their variables player 1 and player 2 to 0. Now the player scores sit within a shape, and it's SHP P1 score and SHP P2 score. And what we do is we apply the score to that shape, in this case 0. We get the game speed from the user, that's from the interface. So we set the variable DBL timer value to FTM game speed. FTN game speed is a function. FTN game speed is a conversion of what the user puts in. The user will put in a value of 1 to 5 in the user interface, and those values are then converted into time. And these are fractions of a second. So we can see that from the Pong sheet, the named range, game speed, gives us a value. So if the value is 1, then we're going to get set game speed, the function game speed, equals 0.5 of a second. Likewise 2, 0.1 of a second. And this goes on. And we can change these as we want. We can add new ones if we want to. We just need to change the user interface. So back to our game. Now we have get baton speed from the user. And once again, this comes from the user interface, and it comes from the named range n baton speed. And this is the number of steps that a baton will move at a key press. So the lower the number, the slower the baton will move. Gets ball speed from the user. And again, this is the same thing. It updates the int ball steps from a named range n ball speed. And again, it's the number of steps the ball moves on each iteration of the game. The next thing we do is we hide the cursor, because we don't really want the cursor in the game. We want to be able to move the paddles around, and we don't want the cursors in the way. So what we do is we hide the cursor behind the new game button, and that is range BP16. And now we go on to our game loop and we call gameplay. And we went through gameplay earlier, and it's the same as on the snake game. And the game keeps running through until we get to a game over state. And finally, once the game is over, we show the user a message box with its title Game Over, and the message is select new game to play again. And then we reset on keys and the code ends. Looking at timer key state and gameplay, our game loop is we go to game timer, and we've been through that before. The call before that is move the ball, and move the ball resides in MDL game, and this is where the logic of the game lies. So if we go over to there, move the ball, first off we test for baton collisions, and this is done via a function, and the function ball collision, and we pass that function our ball position. We can see here that we're using the array that we set in area. So we've got ball area 0, ball area 1, ball area 2, ball area 3, and then we pass the baton areas. So we've got the left baton areas and the right baton areas for 0, 1, 2 and 3, and we pass those to the function ball collision. Function ball collision, as we can see, is taken in these variables that we gave it, and it returns a boolean, so it returns true or false. So here what we're doing is we're testing the ball pixel positions against the baton pixel positions, and what we're trying to say is if the ball position is anywhere within the baton position, then we're going to say that there's a baton collision and we're going to return true. Otherwise, we're going to return false, that there is no baton collision, and that means the ball can continue on its way. So first off, we test the ball's collision with baton 1, and we say that if there is a collision, we're going to see which section of the baton has made contact with the ball, and then we're going to give the ball a behaviour based on where it lands on the baton. So we can give the ball different behaviours depending on where the contact is with the baton, and this is done through the function ftn baton section. ftn baton section. So ftn baton section returns a segment of the baton which the ball has collided with. The calculation is in pixels. E is either end, and I've given these percentages. Middle is the middle of the baton, and the top and the bottom both have a section. So we're splitting the baton up into two ends, a middle section, and two groups between the end and the middle for the top and the bottom of the baton, if that makes sense. We declare a set of variables just to capture the values that we want, and then we calculate segments of the baton. So if our baton bottom is 150 pixels and our top of our baton is 100 pixels, then the bottom minus the top will give us our baton length, which will be 50 pixels, and we know it's 50 pixels because we've set it. The next thing we do is we now calculate our segments of the baton. So the top end of the baton, we're going to take our value from our first calculation, which is the size of the baton, and we're going to say, okay, we want 3%. So we take our 3% of that for the top section. And it has a bottom section, which is also 3%. The next sections are the main portion of the baton, which is the top segment, which is 38%, and the bottom section, which is also 38%. And finally, we have a middle section, which is 18%. The next thing to do is calculate the halfway point of the ball. So we apply that to another variable. And the reason we want the midpoint is because we're going to do our calculations based on the midpoint of the ball. Otherwise, if we just took the ball's Y and X position, that would just give us a top left point of the shape. Now we move on to a select case, which returns the baton segment as a string. Back to ball collision. We set the value of ball collision function to true, and we exit the function. Now, if the first contact is not made with baton 1, then we test that it's made contact with baton 2, and we follow the same process. We find out which baton segment where the collision has been made, then we return a true for the function ball collision, and then we exit the function. Else, if the ball has not made contact with the baton, then the ball collision return is false, and we can see here that we've set it as Boolean. Going back to move ball, we apply the results function ball collision to ANS, which is short for answer, which is a Boolean, so it'll either be true or false. We set the ball direction of travel after contact with the baton using an if statement based on our true and false in answer. And we use a with statement as a shortcut in the code to reference the ball class. On contact with the baton, always change direction left to right or vice versa. Here we're using the midpoint of the game, and we're saying that if the ball is less than the midpoint of the game, then the direction has to be right on contact. So we're saying that if the ball is in the left court, half of the court, and there has been a collision with paddle 1, then the ball must move from left to right, and we set direction to R. Else, it means that the ball is in the right part of the court, and it must move from right to left, and we apply L to direction. We set the behaviour of the ball where it collided with the baton, and this is where we collected the segments of the baton. We apply the up, down or horizontal plane of the ball. So we've set its left to right movement, and now we wish to know whether it goes up, down or horizontally on the court. We use a select case for this. So as we can see here, TE, and we're making the plane U. If the plane is T, if the plane was U or the plane was H, then the plane is going to be U. Else, the plane is going to be down. So we're saying whichever direction, up or horizontal, when it hits the T segment, which is the top segment, not the top end, but the top segment, then the ball is going to move up. Else, the ball is going to move down. The middle section, if the ball makes contact, then the ball is going to travel on a horizontal plane. The bottom section, if the ball is traveling down or on a horizontal plane, then the ball is going to travel downwards. Else, the ball is going to travel up. And finally, the bottom end, if the ball hits the bottom end, then the ball is going to go down, no matter which direction it comes in. And that's how we adjust the ball's plane on contact with a baton. Based on a segment, it will either move horizontally, up or down. The next thing to do is actually apply those movements to the ball. We're going to move the ball along a vertical plane. As plane, we're going to select the case plane. If plane is U or plane is D, then we're going to adjust the Y positions of the ball, and we're going to adjust it by the steps given from the user interface that we collected earlier. We move the ball along the horizontal plane as direction, and this is where we give it its left or right position, and we send that. Finally, we test for score and who won. If the ball is out, we test direction for R and L, and if it's R, then it means that player 1 has scored a point because player 1 hits the ball from left to right. If the case is L, then we update the score for player 2 because the ball moves from right to left when player 2 hits the ball. We also give game over a value from a function update score. Function update score. Update winning player score P1, P2. Test for winning score. Return true means a winning score. Return false, the game is still in play. This function returns the score. If it's called from player 1, then it increments the player 1 score, and it also says that player 1 will serve the ball. So we're looking for the baton area, and we're going to serve the ball from the baton area. And so if player 1 scores, player 1 serves. And likewise with player 2. If player 2 scores, then player 2 serves. And we do a calculation from where we want the ball to come from the baton of player 1 or player 2. After that select case, then we call ball direction. Ball direction gives us a random plane for the ball. So we know which direction the ball is going to come from. If player 1 won the point, player 1 is going to return the ball. So the ball is going to move from left to right. So the direction is going to be R. The plane, we don't know whether the ball is going to move up, down or horizontal. Here, we set the plane randomly in ball direction. So we set an array up with our string values. We create a random number generator, and that random number generator then applies the array element randomly selected to the ball plane, and that's how the ball is returned. So we don't know whether the ball is going to return up, down or centrally. So that's ball direction. Next we test whether the score is over and whether it's the end of the game or not. And here we're saying if P1 score is higher than the game over score, int game over score variable, or P2 is equal or higher than the int game over score, and that comes from the user interface as winning game score, then we're going to return true for this function. So as we say up here, if it's true, player 1 or player 2 has a winning score. If it's false, we continue playing the game. If it's false, we also have to do a return, a serve. If it's false, we also have to serve. So whichever player won the point serves. So game over is given the value of true or false. If it's true, then the game ends, and if it's false we continue playing. And here we run the endgame process if the game is over. An endgame is on key timer state, and it switches the bowling value for B on off to false, and that stops the main game loop. A quick review of the subroutines. Ball direction, we've been through clear objects, clear shapes, clear baton, FTN ball collision, FTN ball section, FTN game speed, FTN update score, move ball, new game, update score. We've been through all these. Module on keys. We have declare keys and reset keys, and then we have the procedures for press up, press down for the baton movements. MDL timer state, end game, which we've just been through, gameplay, which is the main game loop, game timer, and this sets the speed of the game but also listens out for events, so that's the keyboard input from the user. And that's the coding for the game. The Pong game was a bit of a demonstration on using classes, creating classes and using them within code. It uses the same sort of game design as a snake game in that we wanted to get user input via the keyboard, and we kind of polled, we had that loop that polled the keyboard input and also tested the input against a set of rules. And the set of rules for the Pong game were, is the ball in or out? If it's in, then which direction of travel it's moving, and is it moving up and down? How to bounce the ball off a boundary, how to recognize a boundary. And if the ball's out, what do we then do? And in this case, we update the score. We test the score to see whether it's game over or the game's still in play. And the score also defines who's going to serve next. So if you win a point, you serve. And we didn't just want to serve any old how. We wanted to serve from the winning player. We serve from the winning player's paddle. And we randomly select the plane of the ball so it can move up, down, or along a horizontal plane. The other thing we wanted to do, we wanted to get some input from the user, and so we get the winning score, the threshold. So you could set it as it is here to the first one to 3, or you could be the first one to 10, first one to 21, whatever you want. The game speed is the speed in which the main game loop moves around. The baton speed is the number of pixels the batons move at a time. Now the larger this number, the bigger the jump there is, and it helps the game move along a bit quicker because the game is very dependent on your CPU speed. And the ball speed is just the same as the baton speed. If the ball here, the ball speed's 1, and for each time you press the arrow key up and the game iterates, it moves 1 pixel. So increase that and you increase the speed of the ball. So hopefully you enjoyed this game, and I'll see you in the next one. Take a look at the other games that I've produced. Each game has a slightly different way of implementing that game. I'm trying to introduce new elements of VBA into each game, ones that I haven't introduced before, or expand on an existing element that I've already used. If you like this game, please subscribe or comment.